Most substances are mixtures. If you want one component of that mixture, you've got to figure out a way to extract, remove, purify, that is, separate that component from the rest of the mixture. You'll use a difference in one property to accomplish that separation. Our chemistry tree classifies substances as either pure or mixtures. Pure substances are either elements or compounds. Elements are either metals or nonmetals. Compounds are ionic or molecular. Here are some properties we might be able to use to separate one substance from another. You're given a sand-water mixture. Stop the video and figure out how you would separate this mixture into sand and water. And the answer is, you would pour the mixture into a funnel. The sand gets trapped in the funnel and the water passes through. To separate a mixture, you want to use a difference in a property to accomplish that separation. This table shows a few common methods to do a separation. Stop the video and figure out how you would separate these two mixtures. For the sand-salt mixture, use solubility. Salt is soluble in water, whereas sand is not. So add water to your sand-salt mixture. The salt dissolves, the sand does not. Then filter to separate the sand from the salt-water mixture. To separate the salt from the water, use a difference in boiling point. The ionic compound salt has a much higher boiling point than the molecular compound water. So heat this mixture to the boiling point of water. The water boils off, leaving salt behind. Soda is mostly sugar and water, so stop the video and answer these two questions. Sugar and water are molecular compounds. Sugar has a higher boiling point than water. So to separate the sugar from the water, you would heat the soda to the boiling point of water. The water boils off, leaving the sugar behind. You're celebrating the end of a long week, but you find your adult beverage needs more spirit. Stop the video and determine, how do you make your beverage more spirited? You could use distillation as your separation method with a difference in boiling point to accomplish that separation. So heat up your ethanol water mixture to the boiling point of ethanol, leaving the water behind. The ethanol is a gas, so you want to cool that gas by passing it through a condenser to condense it back to a liquid. So here is your more spirited beverage. When sugar is fermented, ethanol is produced at about 13 to 15% concentration. To increase the concentration of the ethanol, you have to remove water, and that's done by distillation. Distillation produces 95% ethanol. That's 190 proof Everclear. Here's the reason why you can't get 100% ethanol by distillation. In this video, we learned to separate one substance from another by using a difference in a property. You're watching this video on an electronics device. At the heart of your electronics device is silicon. Stop the video, read how silicon is purified, and then answer these questions. And the answers are: solubility and melting point are used to purify silicon. Silicon has a melting point of 1414 degrees Celsius, iron 1538 degrees Celsius, aluminum 660 degrees Celsius, magnesium 650 degrees Celsius, and calcium 842 degrees Celsius. Aluminum could not be used in a crucible because its melting point is only 660 degrees Celsius. It would melt. Quartz is usually used as a crucible. The melting point of quartz is 1700 degrees Celsius. In the Czochralski method, a pure solid silicon crystal is pulled from the melt. As the seed crystal is withdrawn, the concentration of impurities increases in this liquid melt. The entire melt could not be used to make a silicon ingot because then it would contain the impurities. Carbon and oxygen are allowed to have higher concentration because those two elements are electrically inactive. If you want the latest, greatest electronics device, there are a lot of elements, in particular rare earth elements, that go into each device. If we want to make sure there's enough of those elements, we've got to recycle our electronic devices. To recycle means we got to separate the elements from other elements, so we've got to apply those properties again to accomplish the separation.